Hello, welcome back to the channel for a very interesting Python tutorial focusing on supply chain analytics. In a previous video, which was a 1 hour long tutorial, we have built together an inventory simulation tool. The idea was to create a Jupyter Notebook connected to some core modules to visualize different inventory management rules and understand the impact of demand variability and lead time. Today, we are going to the next level, and we are going to deploy that solution in the web application using the Streamlit framework, so you can share the solution with colleagues or customers. If you are not familiar with Streamlit, it's a great way to prototype your analytics tools. At the end of the video, you will be able to create and deploy any analytics tool in a user-friendly app that is accessible online. If you miss the first part of the tutorial, I recommend to watch it first. But don't worry, you will be able to follow us with the source code that is shared in the description. Today, our goal is simple. We are going to take the core modules that we have built together in the previous tutorial to generate visual in a minimalist single-page app. As soon as you click Run, every time you change the parameters on the side panel, the visuals will be automatically generated. So now, we can test all the different scenarios that we have used to study inventory management rules in a friendly user interface. We will do it step by step. And at the end of this tutorial, you will have a working app ready to deploy, and I will show you how you can do that for free, that you can share with anyone using a link. The entire source code is shared in a GitHub repository that you can find linked in the description. If you want to start deploying your first supply chain analytics application, just follow me. So before starting the tutorial, maybe let me show you how the result looks like. So as I promised, your app will be deployed. Here you can access my version of the deployed app using this link. Let me go in full screen now. So here on the left side, you have the different parameters, and I will explain you what these parameters are doing. If you're not familiar, if you didn't follow the first tutorial, I recommend you do that, but if you didn't, I will give you a quick recap just after. As I told you, just click Run Simulation. Here, the visual appears. And as soon as you change the parameter, for instance, here I put 2 days of lead time, the visuals are automatically calculated. What you can see here is that, for instance, when I add lead time, the inventory in hand is going below 0. But if I adapt the inventory, the ordering method, considering the lead time ordering, then it's getting back to 0. If I add a bit of stochasticity, let's be nice and put 0.5. Okay, what we can see is that is going, the inventory is like going anywhere because the rule is not adapted to what we would like to do. But as promised, here is what would look like the result. And this app, you can access it on your machine. So your app will be accessible to anyone using the link. And to be honest with you, you will see at the end of the tutorial, it's very easy. And I haven't used Streamlit for a while. It was very easy to deploy. You don't even need basics of deployment. You just need to share your GitHub repository, and then Streamlit is taking care about everything. So now let's go more into details. First, maybe starting with a quick recap so you know what we did in the previous part, and then let's go start encoding the web application. So if you haven't watched the first video, here is a quick recap of what we did in the first part of the tutorial. So first and foremost, here is the GitHub repository that you can find in the description of the final results of the tutorial. If you look here, so here I've just added the virtual environment, but you won't have it in the GitHub repo. So you have a Jupyter Notebook where you will have the different simulations, and I will show you how to use it. And then we have this folder inventory where we have a file called inventory analysis, where you can find all the different functions that are needed for the simulation. And then inventory models, where we define the pydantic models for the input parameters of the simulation. So basically what we did, let me give you the context, right? Let's imagine that we are supporting a retail company that has multiple stores across US, for instance. They manage multiple SKUs, maybe like 10,000 SKUs. And for each SKU, they are storing these products inside the stores. Every day, customers comes to take them. So this is the demand. Buy them, this is the demand. And every time the inventory is below a certain threshold, the store is sending an order to the central warehouse where products are packed in boxes, put on pallets, and delivered to the store. So all this mechanism is called inventory management. And the idea here is to understand what is the most optimal rule to trigger these replenishment rules to minimize the average inventory, because it's linked to the cash flow of the company, but also the space that you need in the stores, and avoid stockouts. What is a stockout is basically when the inventory is at zero and you have demand from customers. So for that, we need to simulate this inventory management. And that's what the exercise that we did in the first part of the tutorial. So here in this visual, that will be the visual that we are going to design for the web application. You have 3 different parameters. The parameter in red is the demand. And here we are supposing that we have a stable demand. I think it's like 5.5 units. The idea was to take demand per year. And here the scope is 365 days, so it's a full year. And we divide by the number of days to have an average. Then in green is the inventory on hand. So how many items you have stored in the store. And the first exercise that we did that you can find in the functions of inventory analysis is to create this mechanism of a day passed, 5.5 units have been consumed. So my inventory level is the one of yesterday minus 5.5 units. And this what basically create the connection between the demand and the inventory on hand. That's not only what we did. The second thing that we did is to create, so now this is on the demand part, then we have also the supply. So every time that an order is triggered, so the store is ordering to the warehouse, products are delivered to the store, so the inventory level is offset. So for instance, if you receive this morning like 50 units, then your inventory is not anymore 0, it's like 50. So the first step of the long tutorial that we did last time was to create this mechanism. Then we can test multiple strategies of ordering and see the impact on the inventory on hand. And that's what we did in this tutorial. So maybe let me go in the README. So first, maybe let me just import here, and then I will test the different scenarios. So as I told you, the objective here is to have a tool to test multiple scenarios. And in the README, you can find the different scenarios that we have tested last time. So the first scenario is to assume that we have a lead time of 1, so which means that between the time you order and the time the inventory is updated, you have 1 day. Well, basically, you order today, you receive tomorrow. We have a fixed demand, stable demand, and what we want to know is what is happening. So I think it's this parameter. So the first scenario is the baseline. So we assume that we have a lead time of 1 day. So if you order today, you receive the product tomorrow. The demand is stable. What happens? So here, we fix the lead time at 1 day. We have this stable demand. What we order is, and we order every t days, and I think t equals 10 days. And every time you order, you basically order the quantity that you need between 2 ordering time. So for instance, here you take the average demand of 5.5 days. You have 10 days, it's roughly 55 that you will order. What happens? Your inventory on hand is getting close to 0, but never reaching 0, or like never being below 0, so you don't have stockouts. So this is the baseline. Then we introduce more lead time. So let's imagine that warehouse is busy and they don't need 1 day, but 2 days to reorder. And what we could see here is that now the inventory on hand is going below 0. And then we start to test multiple other scenarios, trying to compensate the lead time by adding some quantities, seeing that it's not going well. Then I think in scenario 4, we have changed the rule. So here is the exact same lead time, but now in the way that we are ordering, we are compensating with the lead time. And what we can see, we come back to the initial solution. And I think in the end, what we did here is we calculated the economic order quantity. So what is the optimal quantity to reorder and what is the optimal time between two reorder. And in the end, I think that's where we introduce some variability. And what we could see is that then with a deterministic rule, things are going chaotic. So what you could see here is that to test some different scenarios, I had to manually change the parameters. It's not really practical. So the idea of today's tutorial is now to deploy the solution using this core module here into web application using Streamlit. Let's go. Okay, so now we can start coding. So we are on VS Code. I have cloned the tutorial part 1 repo, and I removed what we don't need, which is basically the Jupyter Notebook. We kept the inventory folder with inventory analysis and inventory models. If I follow the README that you can find in the new GitHub repo, the first step is, so here is how the project structure will look like. So we will have a file that we can start to initiate here, like a Python file app.py. It will be where we are going to code basically the single page app. We will need a requirement file. So this is where we will have all the libraries that we need to download to run the application. And so I will take them from the README. So here I explain how you can do it using PowerShell. So PowerShell with pip if you are on Windows. I am on Windows, but I am using Windows Subsystem Linux. And if you are not doing that, I strongly advise you to do that. But in case that you are coding on Python, on Windows, here you have the complete steps, all the different steps to set up everything using Windows. So on my side, I'm using Linux. And here for the package manager, I'm going to use UV. You are going to use pip. And if you follow many Python tutorials now, UV is in the trend. So to be honest, yeah, the best change I did was to install Windows Subsystem Linux on my Windows machine to be able to code in Linux. So I just here take the different libraries that we are going to need. So if you are not familiar with requirements files, it's basically a file where you keep all the libraries that you need to be able to run your application. And what we are going to do is we are going to set up a local environment. So we are not going to install these libraries on your Python, on the Python of your whole complete machine. We are going to create a local environment, so local version of your Python environment, only for this folder, only for this app. That way, inside your machine, you can have multiple environments where you may have libraries that cannot be together. And also for if you want to share this app to someone else, basically this person can install the app very easily following the steps like I did here with my README file, where you will be able to install this application without following the tutorial, just following the README document. So let me just copy here, paste the different libraries. Then I will initialize a UV project, the UV init. And here I will install virtual env to have the local environment. And I will copy and paste this command to activate the environment. And here I will copy and paste this command, which basically helps me to install the different libraries that are listed in this file. It's done. So now we are ready to code. Yes, what we need here is to ensure that inventory is considered as a kind of a module. We will just add this Python file. Sorry, why am I not able to copy and paste? Yes, you can keep it empty. It's when we are going to define here on app the modules that we want to import. Thanks to this Python file, it will be considered by Python as a module and not a folder. So I think we're good. Now we can start to import the libraries and set up everything that we need to So what we need to import is NumPy, import NumPy as NP. Then we need matplotlib, pyplot as PLT is for the visuals. We need Streamlit as ST. And then what? Oh, sorry, I have. Then we need to have by the different modules that we have built in the previous tutorial. So from inventory analysis import, and what do we have here? Inventory analysis, inventory simulation. So boom, inventory simulation. Then we do the same for the models, the Pydantic models. So here, inventory models, and we import, and how they are called, inventory params. So inventory params. Then what we need is, so the last scenario, we are going to simulate the impact of stochastic demand. So our demand will be following like a normal distribution. And for that, like we are going to implement some randomness, and to be able to replicate, to reproduce the same scenario, we are going to implement a seed. And we are going to set the value at 1991 because it's a great year. And then we are going to set the seed at this value. So that way, all the functions of NumPy that will use random will use this seed, and the functions of NumPy that will use random is the one that we are going to, that is, I think, inventory analysis. I'm going back to the app. So now we have all the libraries that we need. We need to set up some parameters for, we need to create our Streamlit page. So we use this function, set page config, and we are going to put a title. And the title is going to be inventory simulation Streamlit. And so let me see. Streamlit. What happens now if we try to, oh, wait a second, clear. Streamlit app.py. Wait. Streamlit run app.py. Okay. So this function Streamlit run app.py will help you to, is basically the command to run the application. Now this this application is run in our local machine. And here, if you go on the page localhost, what you have is a blank page. And settings. And here what you could see is that the appearance is not white. And the first parameter that we need to set is to have a wide setup config page, and I will show you why. So here is my app. Settings, if it's not wide, it's going to be like this. To be honest, I would prefer to use the complete screen, so that's why we need to set it up as wide. So going back to the code, there is a function called, there is a parameter called layout where we should put it at wide. And I don't know if it's on dev mode. Always rerun. Now, normally, yeah, the appearance is at white. Okay, great. So now we have a kind of an empty shell where we have our page. So we should set up the rest of the functionalities. Okay, so going back to the final results, what we want to do to have this side panel. So actually we can hide it. So here you see the added value of having the white screen. So we are going to set up this side panel that will be used to store all the different parameters and our button run simulation. So let's do that. So now we are going to build what I called in the code that I have shared, the minimalist sidebar. It's a sidebar is like that I showed you with only the different parameters. So sidebar, we use the object sidebar. And in it, so we need to put the first parameters. So here, I would like to go back to the final result. Let's go back to the... So the first thing is here is a kind of a title of the sidebar. Here, what we could use, what I used to have this format is only like simple markdown. And you will see we have an object markdown in Streamlit that can help us to write markdown in the user interface. And then here, what we have is, so all these buttons, since not buttons, like objects to put parameters are called number input, where you can increase with different steps, where you have default values. So this is what we are going to put. On each of them, we need to put the default value, the minimum, and the step. Each time you click, what is the incremental value that you change, and of course the name. So we are going to do that, and then we add this radio button for the selection of the ordering method. And this is basically from the code side, which function we are going to take for the simulation, and then the button run simulation. And I will explain you the mechanism that we are going to implement to ensure that. So if I refresh, right? The first time we need to click on run simulation. And then if I change the value, the visual is automatically generated. So we need to create a kind of a mechanism to ensure that we don't need to re-click every time to run simulation, and I will explain you how we can do that. So let's go. Okay, so now back in VS Code. So we have the sidebar. Maybe let's fill it with a title. Okay. I think it's bold. So inventory parameters. Then let me show you what happens when. So the first parameter is the demand, right? So we are going to use the object number input. The first parameter is the name. So here is the annual demand D in units per year. Then we have, so the first parameter that we need to put is the minimal value. And here's going to be 0. You can have negative demand. or I mean, there is no point of simulating with 0, so we put 1. The default value will be 2000 based on the previous tutorial. And the step, I mean, 2000, let's put 50. I think it was 50, right? Okay, so let me show you what happened now on the page, you know? So here, this is the final results. We don't care. No, that's the GitHub repo. Oh, you see, so we are on dev mode. Everything has been updated. And here we have inventory parameters and our button, okay? A quick check here in Markdown. If I want it to be bold, I need 2 stars, okay? So now we need the same button for like input field for the total T total, which is the total length of the simulation, like a simulation period. The lead time, we need the T, so the number of days, I forgot the name, the actual name, the review period, sorry. The number, which is the number of days between 2 ordering time. So let's imagine that, for instance, as an inventory manager, you look at the inventory every 2 days. So between if today you order, you will wait 2 days to recheck the inventory and check if you want to order or not. Okay, and so wait, maybe let me do that properly. So T total. So the total here, how we call that? So it's the simulation horizon in days. Here is the lead time. Lead time LD in days. And here it's the cycle time, the review period. See, actually, the cycle time it's more like the review period, but I call that cycle time. I will keep that. So here, just let's set up the values. T total, it will be 365 days. The default value. Step, I will put 1. Lead time. The default value is the scenario 1, so I think it's 1. The minimal value is 0. Let me put 0 here, it's okay. And step 1. The cycle time, 10 days, I think, the default value. Let me check. Yeah, 10 days, step 1. Then what's remaining is Q, the quantity you order every time you order. Call that Q. And I will call that order quantity Q in units. Minimal value. So here it's going to be a float. Minimal value 0. Default value, it's 55 in our example. And the step 1. And here, I mean, if I check my notes, yeah, we have to, I mean, for just the visual, let's put some format. So the format should be only to, yes, like this. Okay, which means that, which force the format to be at only 2 figures after the point of the comma. So yeah, we good. Let me maybe increase. Okay. Back here. What do we need in there? It's the inventory on hand. So if you haven't followed the first the initial inventory on hand. So initial IOH, and here number input. So the initial IOH is initial inventory on hand. The minimal value, so here the minimal value will be 0. And I think the initial value it's 55 also. It's the value of the quantity that you are going to put. So the initial inventory on hand, it's basically when you start the simulation, how many units you have in stock. And the step 1.0, here, same exercise. We have to have a nice format. Up. What else? Don't worry, we are nearly finished. So here we have, so I will copy and paste multiple times. Here we have the last parameter. Let me go back. Yeah, don't worry about this. So we did an initial inventory on hand. So the last parameter is the daily standard deviation. So I will copy and paste directly. Boom. It's going to be sigma. The initial value, it's at 0.0. And the step, 0.5. Nah, 0.1. We don't care. And then we don't need. So we are done now. If I go back here, we are done with, with the different input fields. Oh, we need the radio button. So how do we define the radio button? And here the radio button would be for the ordering method. So call that method. So object radio. In the object radio, we need to put the name. So ordering method. And then you need to put the options that are available. And for that, to be honest, I will copy and paste. Simple ordering and lead time ordering. Okay. The default value, I think we need to put. And for that, we need to use, index 0. Let's say like the simple ordering, like that's the first method. You know, if you follow the different scenarios, we use a simple ordering, then we put a lead time, and we see that it doesn't work. Okay. Then later, I think what we are going to do is use this value to select the functions. So for that, I have defined this parameter, this variable method key that could be equals to order lead time. So if we use the second function, or the order, the classical order, which is simple ordering, and it would be equal to order lead time if method equals lead time ordering. Then boom, equals lead time ordering, else it will equals order. So this will be used later to select the different functions. And if I go back here, considering, depending on, are we going to select this function, where you have an ordering method that considers the lead time, or are we going to take this function that doesn't consider the lead time? Oh yeah, this one, that's not considering the lead time. So simulation 1 or simulation 2. Okay, let's go back to the app. Yeah, so then we need the button. So the simulation button, I forgot. Yeah, it's just a simple button called run simulation. And we need to set up as the type as primary, because this is what will this is the style of the button that you, and as is the only button that we have, let's put it at primary. Okay, let me go back here. Okay, so we have exactly the same. The thing is, I told you that we have this mechanism, right? Where when you click on simulation the first time, so when you arrive the first time, you need to click on simulation. And then if I change the parameter, so here, for instance, I change cycle time, I don't need to re-click again. So there is a kind of additional variable that we call state variable in Streamlit that will record the fact that run simulation has been clicked already. And then that will, where we are going to put a logic where every time you change the parameter, everything is loaded automatically. So for that, we are going to define the state variable. So if I go back here, I think we can set up state variable to for run. Okay, so, and let's call that as run. So the state variable, you can consider that as a dictionary that is stored every time you run with values in it. So here we're going to have in the dictionary, in the key has run, a Boolean that with true or false. True if you already clicked on run simulation, false else. So if has run, so here we just check if this key has run is not in the session state, and this session is for every user. So, and everything is managed by Streamlit. So if has run is not in state st.session state, we are going to define it session state, and here we are going to define the value of the key as run as false. And if run is true, if run, then we can put st.session state dot has run equals true. And you will see later how we use that to for the mechanism of updating the visuals every time we change the parameters. So here is now the complete sidebar that we have. So now we can go into the core of the results that we want to visualize. So now that we have finished the sidebar here, we can focus on the main content. So we are going to set a title. We are going to put these cards, which are basically reminding the users in case they hide the sidebar, which are the main key input parameters that are used to simulate the inventory management rule that we see here. Then we will have the core part of the visual itself. And then we will have these three different, I would say, like, we can call that cards or like blocks of that are showing the results. And this nice message that is changed based on if you have based on the status of the session state value as run. If you haven't clicked yet on run simulation, it's gonna be, you're gonna have the message. Or maybe let me show you that directly. So yeah, you will have this message saying set your parameters on the left to click run simulation, and then when you click, the message was going to be updated. So yeah, that's these three parts that we need to do. It's going to be very easy. Just follow me. So now we are back in VS Code. So I just create a section like main page, not the sidebar. So the first thing first is the title, inventory simulation web application. Here we need to have the daily demand, because that's going to be the first value that we are going to show in the different cards, and it's not calculated here because here you have the total demand, the annual demand, and then you have the horizon, so you need to calculate it. So it's called D-Day. So daily demand, daily demand is going to be D divided by T total. Okay, great. Then the next step, it's going to be to create these cards. And for that, I wanted to have this nice formatting. Let me show you, like with this rounded square, this specific font. And for that, to be honest, I asked Claude Desktop to generate me a nice CSS for this. So what I'm going to do is I'm going to copy and paste a specific function. You can do the same using the GitHub repository that I have shared in the description, and I will explain you what you have inside. So here we are defining some CSS. If you're not familiar with web programming, CSS, it's basically a way to define the format of specific HTML content on the graphic side. I'm really not good at it, so I would not be able to generate that myself, but the final result was interesting, so I wanted to use that. So let me maybe here formatting of input parameters card. So here is the CSS. So what we define here is the style of specific HTML content that will be defined using classes. And here on this function, we are creating a function that will take two values, so the label and the value, two parameters, sorry, the label and the value, and generate this HTML object that will be the card. So this function is generated the HTML object, so the box, like the square with the content. And here, this CSS is a kind of refinement of the graphic visualization of this object. So a bit of HTML programming, like on Streamlit, you will see. When you will learn Streamlit, when you will want to improve your Streamlit interface, you will quickly go into web programming, and this is what I did in the past. So if you're not familiar with that, don't worry. By playing with it, by learning, especially with the support of LLMs, you will be more familiar with that. But let's consider that here is just formatting block. And maybe we can do the experiment of removing that and see what happens. So then what we need to do, so let me again go back to the final result. We need to define basically all these objects. And here what we have is multiple blocks in the same line and for that we can use the object columns of Streamlit. So for that we are going to use, let me show you, st.columns with 6 elements, and we are going to define the 6 variables that will contain the different parameters that we want to show inside the boxes using the function quickCard. So let me show you how it works with the first one. So C1, the one on the left. So we are going to use quickCard. Let me just go back here to the example, sorry, not here. So it's the average daily demand in units per day. Okay, back to VS Code. Average daily demand. Here, what we could see is that we only have, so we use D-Day that we have defined below, like above. But here we only want to have two numbers after the comma. So we use this formatting. And here we need to put units per day, which is the unit. So the label is average daily demand. That's the value, and that's here units per day, the unit. If I go back here, yeah, and what we can see, it's exactly the same. So then we will do the rest for C2, C3, C4, C5, C6. So for that, I will just copy and paste what we have in the GitHub repository. What I can see here is that we have an error. Sigma is not defined. Did I forget to put sigma? Yes, I did. Here, sigma st number. Yeah, so we have, yeah, I haven't changed the input parameter name. And now, if we go back here, we should have the 5, 6 cards, exactly the same as this one. So now we're good. So we can start building the visuals. And for that, I will show you a trick. I mean, a way to gain time. So now we are ready to start the calculation and create the visuals. But here we won't have to create everything from scratch because we can already use the calculation that we had defined in the previous tutorial. So just how to trigger the calculation, it's when the session state value has run is supposed to be true. So we go on session, so we create this if condition, session state has run. Okay, so here just put a placeholder, do the calculation. And here, as I told you, we have this message that we are supposed to put if the calculation are not done. So for that, let me just check on the UI. Okay, set your parameters on the left and click run simulation. So if if we haven't clicked no, sorry. Here, so if the value, if this Boolean is false, what we do is we just use the object info, which will provide a message. And here we just put set your parameters on the left and click run simulation. And maybe I will put it on bold. Okay. What happened here? I don't know. 1 equals none. Okay, great. So now what we do is we go back to our previous notebook. So if we go back to what we have built in the previous tutorial, how we run the different simulation, it was quite simple. We have the input parameters, so we can copy that. I will remove here. Oh, wait a second. And then we have the different calculations. And here, so we define our object. And we call that simulate. That is using params. If I want to follow the naming that I used in the repo that I shared, I call that sim engine. And then this is where here we have to define the logic. that will depend on the radio button. So if method key equals order lead time, yes, exactly, then df will take the sim engine with the function 2. And the method will be order lead time. Then if the method key is order, but then it's going to be the second simulation, but now with the method order. We won't use the simulation one. The simulation one, if you remember well, is a function that we have defined at the beginning where we have explained that it's basically not working. I mean, it was the initial exercise, how we could say. And if there is no method defined, we take the first one, but we are not supposed to take it. This scenario is not supposed to happen. But if we have something wrong on the visuals, then we understood that there is an issue that the method key is not defined. Okay, so I think we're good for the calculation. Then we need the visualization. And for that, we can cheat and take the visuals that is already defined in the previous notebook. So that's what I'm going to do here. I'm going to take this. So this part is exactly what you had in the Jupyter Notebook. And then I added this just to ask basically Streamlit using the object pyplot to plot this figure that has been defined here with the parameters clear figures and use container width. So use container width is like you want to use the entire width of the block. So let's have a look. Okay, so now we arrive here. So we need to click on simulation. And now we have the visual that appears. And yeah, I mean, the way that we have cheated is like, we didn't have to rewrite the entire code because it was working already very well in the Jupyter Notebook. The only thing here that I want to check if I put the lead time at 2, it's going to be below 0. And if I change the lead time method, yeah, so the mechanism is working well. So then the only remaining point, but I think you can have a look at it by yourself, is probably like here, these 3 different parameters results that you want to show. And to be honest, I don't see the point. I don't know why I have put it that way. I wanted to keep that minimalist. But what is important here is that, so now your app is working quite well in your machine, but you want to deploy it. You have here a button called deploy. And then Streamlit propose you for free to deploy the solution on their instance. And for that, you just click on deploy. And then what you need to do is the same way that I did myself, is to store that in your GitHub repository. And then if you do that, you will not have this error message. Streamlit will ask you if you accept to give them the access to your GitHub repository, and you can say yes. So that way they can directly take the code in your repository, the code that is working on your machine. You don't have to do any changes. And after a couple of clicks, what you will have is these results. To be honest, it's working pretty well. So this app is pretty light, but to show a proof of concept, it's a good way to have something deployed for free. If you want to have something stronger, the same way that I, for instance, deployed the Logic Green app, which is basically a kind of a demo app that we have for my startup Logic Green that we use to showcase the type of analytic solutions that we can deploy. Usually when we deploy, we don't use Streamlit. Streamlit is mainly used for prototyping. For that, I would suggest that you have your own VPS. But it's the same way, it's the same approach. Probably here, the main difference that you will have in the Logic Green apps versus the app that we have deployed here is that I separate the backend and the front end. So Streamlit is only used for the front end, and you have a specific backend using a fast API microservice because you have some algorithms, especially on the sustainability part, that are a bit complex to run, that takes time to run. So I wanted to separate both. And this fast API microservice, this fast API backend can be used with other type of UI. And for instance, when we deploy that for our customers, we use more React app than Streamlit, that is a bit more robust and more professional. But to prototype and to start at least to do web application development, like productization of analytics tools for supply chain, it's a great way to start. So I think it's enough for this tutorial. If you have any question about what we did so far, don't hesitate to use the comment section. If you want to follow the tutorial, I will share with you the GitHub repository of the previous solution that we have deployed in this 1 hour long tutorial, and the final solution here that I have deployed in supply science inventory.streamlit.app. And see you for the next tutorial.